Hello students. So today we will be learning about Kirchhoff's second rule. Okay, I'll be covering the physics numericals based on Kirchhoff's second rule. So first we should know what is that. Okay, in any closed part, okay, if you have a loop of an electrical circuit, the algebraic sum of the EMFs and the products of resistance and current, okay, flowing through them is 0. Okay, so if you want to find out the current flowing through it or resistance through it, you can use that equation. Okay, so we'll start with some circuit. Okay, suppose we have this circuit. Okay, now we have to write that loop. Okay, so now first thing you should know is that whenever you are taking the product IR, okay, you should know how to write the sign for it. Okay, so if you are moving, okay, against the direction of the current, if you are moving against the direction of the current, the product IR will be positive. Okay, and if you are moving in the direction of the current, then the product IR will be negative. Okay, similarly you have to write signs for EMFs. So if your EMF is, if you are moving from positive to negative, then you have to consider the sign negative. Okay, and if you are moving from negative to positive, if your direction of the current, okay, if direction is from negative to positive, then you have to take positive sign. Okay, now let's write. So now I'll consider the loop PQRSP. Okay, now loop PQRSP. Okay, starting from P, first we have EMF. Okay, so EMF you have to see positive and then you have negative. So ending on negative, you have to take negative sign. Okay, moving forward, here there is R1. So you have to write product of I and R1. Now see, we are moving against the direction of the current. So your IR, that is product, will be positive. Okay, moving forward, so here another EMF is there. So negative to positive, ending on positive, so you have to take positive E3. Okay, moving forward, here R2 is there. You are moving against the direction of the current, so the product will be positive IR2. Okay, then here negative to positive, so ending on positive, and loop ends, so it is equal to 0. So this loop we have taken in clockwise direction. Similarly, if we start in anti-clockwise direction, let's see, loop in anti-clockwise direction will be PSRQP. PSRQP. Okay, so starting from EMF E2, so positive to negative, our E2 will be negative. Okay, now we are moving in the direction of the current. So in the direction of the current, IR is negative. So you have to take IR2 negative. Moving forward, E3 positive to negative, it ends on negative, so E3. Then in the direction of the current, product IR1 negative. Okay, and moving forward, it will be negative to positive, so this ends on positive. So our loop ends at P. So this will be anti-clockwise. Okay, here it will be IR1. Okay, yes. So if you compare both the equations, you will find that both are similar equations. Okay, just we are going clockwise direction in this, and here we are going in anti-clockwise, but we are getting the same equations. Okay.